Now let's study the last transformation, which is called dilation. Now try to read the letters on the fifth line. Come on, make an effort. Read the letters on the fifth line. I see your eyes squinting. I see you looking at it like that. Yes, guess what? Your eyes are already dilating. That's what happens. The eyes dilate. It goes bigger and smaller, right? Sometimes when you do this, you're making a PowerPoint presentation, you got a picture or a graphic and you want to enlarge it. What do? You click it from the corners, right? You drag the corners here and then you drag it so that it becomes bigger, or you either make it smaller. Okay, so when you do that in your computer applications, you are dilating. So what do we mean by dilating? So we have an example of the eye. Your eyes would dilate. Okay, it gets smaller or bigger because when the light hits the eye, the pupil enlarges or contracts depending on the amount of light. Now, that concept, we now put it in math, in geometry. Now, the washers shown in this photo illustrate the concept of dilation. See, from smaller version to a bigger version. Are they similar or congruent? Yes, they are similar. Same shape, but they vary in different sizes. Dilation is a transformation that produces an image that is the same shape but with different sizes. Remember that. Same shape, but different sizes. What else? It could either be a larger version of itself, you call it enlargement, or it could be a smaller version of the original called reduction. Now, look at this. There is usually a center of dilation, the point for as a reference on the dilation. Think of this as the original and think of this as the dilation. Okay, and the distance from here was doubled over there. So based on the center of dilation. The description of the dilation includes a scale factor. It will tell you how many times larger, 2 times, 3 times, or half times. But there is also the scale factor is sometimes referred to as a scalar factor. They mean the same, scale or scalar. In mathematics, the dilation of an object is called the image, all right? The second rectangle here on top is the image. This is the OG, the original, right? And from the clues, the letters doesn't have a prime symbol, therefore this is the pre-image, the original. Whenever you see those prime symbols, this one, the prime symbol here and the prime symbol there, you know that is the image. Okay, so again, the prime symbol gives you a clue of what is the image. Now let's focus on the scale factor. If the scale factor is greater than 1, obviously it will be larger. Greater than 100%. 1 is 100%. You could think of it that way. Next, if the scale factor is between 0 to 1, 0 to 1, like point 2, 1 half, 1/3, 0.75, then it is a reduction. So your basis is 1. Times 1, it's no change, it's the same thing. A figure and its dilation are always similar figures. We've known. Now, again, look at the same image. You were given a scale factor of 2. What do we mean by that? The length of each side of the image is equal to the corresponding side of the original figure multiplied by the scale factor. Check this out. If this side is 5 inches, because your scale factor is 2, it will double. So 5 times 2 becomes a 10. Right? Now, if the measure of your width, let's say this side is 3, so since you use a scale factor of 2, do times 2, this will now be a 6. Okay? It follows the same ratio as the times 2. Times 2 is like the constant. What else? The distance from the center of dilation. Remember, we mentioned the center of dilation to each point of the image is equal to the distance from the center of the dilation to each corresponding point of the original figure times the scale factor also. What do we mean by that? Okay, check this out. From the center of dilation, from that center of dilation, okay, and up to point C, let's say if the distance is 6 centimeters, again, to the new image, it will also what? Match the scale factor. It will also double. This will now be 6 times 2, 12. See? C to C prime is 12. D to D prime will also be times 2. See, it also always follows the scale factor. Now, dilations are enlargements. Remember that. Or reduction if it's less than 1, between 0 and 1 actually. Is this an example of a dilation? Okay, same size, not same size, but same shape. Yes, so our answer is yes. All right, next. Under the dilation shown at the left, the value of the question mark will be what? Check this out. They gave you a scale factor. Oops, it is greater than 1, therefore it is an enlargement. By how much? 1.5. So what do? 1.5 times 2, because 2 was multiplied by 1.5, we will get what? 3. Okay? That side is now 3 units. Under a dilation, the picture shown on the left, this is the one, the picture on the left has been reduced in size. Look at that. The scalar factor was, so what is being asked? The scale factor. You were given two numbers, okay? So what do? Now, if you look at the drawing, it got smaller. So what did we say if it got smaller? Can a scale factor be greater than 1? No, it cannot be greater than 1 because it got smaller. I won't choose you too. So 48 became a 12-inch. Okay, so that means I multiplied 48 by what number? 48 times 1/4 or times 1/2? Look, 12 over 48. 12 over 48 is what? Lowest terms? Yes, 1/2. The length of a small train is 4 inches. So for you, we have your drawing here. You are 4 inches. Okay, 4 inches. The length of this little train. Under the dilation of a scale factor of 2. Whoa, 2 means what? Bigger or smaller? Yes, it has to be bigger. What is the length of the larger train? Obviously, it has to be bigger than 4. It cannot be 2. All right? So, and what do? 4 times 2. There you go. The correct answer is 8. Under the dilation shown on the left, the value of a to the nearest hundredths is what? Okay, now look at this. 2 became a 3, and a was the original, became a 4. So the best way to do this is to make a proportion, right? So let's write it down. So 2, you could write your 2 over 3, okay? Pre-image to image is equal to, start with your pre-image, which is an A over 4. So that's your proportion. It should follow that. So what do you see? You cannot see a pattern, yes. So what can you do? You could cross multiply, that's an 8. 8 times 3 is 3a. How do you solve for a missing number? Um, 3 times what number is equal to 8? So divide it. 8 divided by 3, you will get 2.666. So what would that be? 2.67. Okay? Next. The large blockhead is 6 centimeters wide. After the dilation, So you are a 6, now you're a 2.4, okay? What happened to my 6 and it became a 2.4? It got smaller. So if you look at the choices, if it got smaller, which is obviously wrong, I'm not going to use you. You're not times 3. You did not become times 3. Did you become times 2.5? No. So I multiplied it. Is it 0.5 or 1 half? Obviously, it's not 1 half. Because if it's 1 half, that would become a 3. This would become a 3. So you're not the answer. Therefore, the answer is zero point 0.4 or 4 tenths. What is 4 tenths of 6? And you will get 2.4. See, by process of elimination, you can answer the problem. Next, the important transformation is resizing. Remember, in resizing, these are the vocabulary you might hear: dilation, contraction, compression, enlargement, or expansion. The shape becomes smaller or bigger. Now, sometimes you will be asked to make a dilation in a coordinate plane. Now, the basic thing is this. The scale factor, all right, the scale factor is to be multiplied to the x and multiplied to the y. Remember that. That's the only thing. If I gave you a scale factor of 2, take note. ABC is here. Look at that. That's the inner triangle. Now, to know the new coordinates, because the scale factor is 2, is just multiply everything by 2. All right, so let's look at this. 0 times 2 is 0. Let's look at that. Where does it match? 0 times 2 is 0. 2 times 2 is 4. See that? 2 times 2 is 4. Negative 1 times 2 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 2 is negative 4. See that? Everything was simply multiplied by the scale factor of 2. Therefore, we got the bigger rectangle. I mean, the bigger triangle. Now, check this out. It matches, right? These are the new coordinate points, and guess what? The length will also double. AB will double its size into A prime B prime. What else? CB will double its size into C prime B prime. What else? We know that AC will double its size to A prime, C prime. So everything is times 2, except the angles. Of course, the angles will not double. The measure of angle B is still the same with the measure of angle B prime. Now, we are dilating with a smaller scale factor of 1 half. Everything becomes smaller. So our original is the ABC. All right. So look at the coordinates of ABC. This one. Okay. The bigger quadrilateral. Now, everything will be times half or get half of it. Look at this letter A. Half of negative 2 is negative 1. Check. Half of positive 4 is 2. There you go. Get the half of each of the coordinates and you will get the inner quadrilateral. All right. See that? They all match. Everything is half times 1 half or divide by 2. And what did you do? Simply multiply the x by 1 half, y by 1 half. Okay. And again, what have you observed? Corresponding sides will be 1 half. BC will become what? It will become B prime C prime, and the length is half of the original. Okay? Corresponding sides will be half. Okay? And parallel lines, by the way, parallel lines are preserved. Okay? That parallel line, okay, is also, when it got smaller, this is also parallel to that side. Parallel lines are preserved. And the angles are also preserved. Dilation and similarity. So we learned that every time you do dilation, the figures, the geometric figures are always similar, right? So to check for similarity, triangle ABC, this is ABC, is similar to triangle DEF. F. How do I check that? Simple, just use the numbers. So let's write down. So 4 became an 8. All right, so let's write the 8 on top, 4 below. All right, that's equal to 2. What else? The 6 became a 12. So let's write 12 over 6. So we know what the scale factor is. What else? The 8 became a 16. So 16 divided by 8, all right? If you divide all of those, you will get a scale factor of 2 over 1, meaning the scale factor is 2, all right? So everything was doubled. The corresponding sides and the distance from the center of dilation was also doubled. And what else do I know? Corresponding angles are not doubled. Look at this. A is similar, or I mean congruent to D. Angle B is congruent to angle E. And angle C is congruent to angle F. All right. Thank you very much. Good luck.